So today we are going to learn about transport number and its relationship with speed. So in normal life we see wires carrying electric current. But in electrochemistry we have an electrochemical cell. An electrochemical cell has cathode and anode. Cathode is the negative terminal, anode is the positive terminal. It contains solvent molecules and cations and anions from the electrolyte which carries current. In wires, 100% current is carried by electrons. But in electrochemical cell, there are two charge carrying agents, cations and anions both. There is some current due to cations moving to cathode and some current due to anions moving to anode. And the total current is the sum of both I plus and I minus. Now, since due to several factors like size, charge density, etc., the speed of both ions is not the same in solution. That is, speed of cations is not equal to speed of anions. Let's suppose positive ions moves faster than negative ions. So, in 1 second, more number of positive ions will get discharged at cathode. That is, there will be more flow of positive charge in 1 second, that is more I plus. The same may be possible with negative ions, that is, if negative ions moves faster, there will be more I minus. That is, faster ion will carry greater fraction of the current. Thus, I plus is not equal to I minus, but total current is equal to I plus and I minus. This is where term transport number comes into play. If current carried by cations is equal to I plus, therefore fraction of the current carried by cations will be I plus upon total current, which is I plus upon I plus plus I minus. And this fraction of the current carried by cations is known as T plus, or transport number of cations. Similarly, for anions, fraction of current carried by anions will be I minus upon total current, that is I plus upon plus I minus, and this will be T minus, that is transport number of anions. And this brings us to the definition of transport number, which is transport number indicates the fraction of total current carried by cations or anions in the dilute electrolytic solution. Now let's see an example. If we have a dilute magnesium sulfate solution, we will have magnesium plus and SO4 2 minus ion. If transport number of Mg2 plus is 0.38 and that of sulfate is 0.62, it means Mg2 plus carries 38% of the total current and sulfate ions carry 62% of the total current. Since T plus and T minus are fractions of one single thing, that is total current I, the sum of T plus and T minus is equals to 1.